Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so today we're going to look at the second part of section 8.2. And the first thing I want to talk about has to do with domain. All right, so we have a situation. We have the following function. It says h of x equals 3x plus 6. And it says find the domain of the function. So what we want to find is all of the inputs, all of the x values that when we put them into the function, they produce a real output or range or y value, okay? Now, one of the things we need to be careful of is that we can't divide by 0. In fact, in this section, that's the main thing we need to watch out for. But looking at this function, there's no variable in the denominator, so no matter what real number we put in for x, we're going to get a real number coming back out. We're not going to get divided by 0. So the domain is going to be all real numbers. Now, writing that in interval notation, it would go from negative infinity to positive infinity, parentheses on each end to show that we don't include negative or positive infinity because there isn't an exact endpoint. That's just a concept of forever in both directions, okay? Now, let's take a look at another example. F of x equals 1 divided by the quantity x minus 4. Well, if x was 4, for instance, f of 4 would be 1 over 4 minus 4, which is 1 over 0, which is undefined. So that means x can't be 4, because when we put 4 in for x, we don't get a real output. So the domain is x not equal to 4. But writing that in interval notation gets a little more interesting. We want all real numbers except 4. So we'll go from negative infinity up to 4 by using parentheses on the right of 4. That says I stop right before 4. Then I'm going to skip over and have the union of after 4 up to infinity. So that's all real numbers except for the number 4. Again, the parentheses means we don't include the number 4. Okay, so this is how you'd write the domain in interval notation, which is what you're going to be using here. All right, let's take a look at another example. This says f of x equals 5 over x plus 1. All right, now, in this last example, we saw that when I put 4 in there, I got 0. Here, if I put negative 1 in for x, I'm going to get 0. But let's look at it a different way. Let's just say, when would that be undefined? See if I can write that in actually legible manner. Okay, when would that be undefined? Well, when x plus 1, that is the denominator, equals 0. So let's take that equation, x plus 1 equals 0, and solve it. We get x is negative 1. So when that occurs, it's going to be undefined, which means the domain is x cannot equal negative 1. And writing it in interval notation, it would go from negative infinity up to, but not including negative 1, after negative 1 to infinity, like that. All right? So if it's not easy to see what value or values of x would make the denominator 0, take the denominator, set it equal to 0, and then solve it to determine that. Okay, how about this one? F of x equals 15 over 1 minus 3x. So when would this thing be undefined? You take 1 minus 3x equals 0. If I add 3x to both sides, I get 1 equals 3x. Divide by 3, x equals 1/3. So your domain, x can't equal 1/3 because that makes the denominator 0, which makes the whole thing undefined. And in interval notation, you'd go from what? Negative infinity to 1/3 in the union with 1/3 to infinity. Okay, remember that this symbol means union, so you're taking both of those as part of the solution. Okay, next I want to look at graphing a function. So let's say we've got f of x equals 2x minus 1. That's the same thing as y equals 2x minus 1. Well, this equation is in slope-intercept form. So the slope is 2 and the y-intercept is -1. So how would you graph that? Well, let's take that and let's go back here to where I have room with the graph, and we'll go back to f of x equals 2x minus 1, y equals 2x minus 1. The slope is 2, the y-intercept is -1. Okay, so it's going to go through that y-intercept, and the slope is going to be up 2 and over 1, up 2 and over 1. And we'll draw a line here using a straight edge. And there is the graph of f of x equals 2x minus 1. Let's take a look at another graph. Let's see here. How about this one? F of x equals 2/3 x minus 2. This is also in slope-intercept form. In fact, most often functions are written in slope-intercept form because they write it in terms of y, or in this case, f of x. So if y equals 2/3 x minus 2, the slope is 2/3 and the y-intercept is -2. So -2 up 2 and over 3, up 2 and over 3. Let's see here. Here is the graph of f of x equals 2/3 x minus 2. Okay. Let's take a look at another one. How about this? F of x equals 2. That's like y equals 2. Well, recall from beginning algebra, if you have an equation in the form y equals a constant, that is going to be a horizontal line passing through that y value. It's as if though we had y equals 0x plus 2, okay? So the y-intercept is 2 and the slope is 0. Well, the slope of what is 0? The slope of a horizontal line. So this is the graph of f of x equals 2. Okay, now we're going to look at some information, and on the way we're going to review a lot of concepts from beginning algebra. First of all, let's talk about x and y intercepts. What are x and y intercepts? Well, if you have a graph, okay, where it passes through the x-axis would be the x-intercept. Where it passes through the y-axis would be the y-intercept. The coordinates of the x-intercept, the y value is always going to be 0. The coordinates of the y-intercept, the x value is going to be 0. So to find an x-intercept, set y equal to 0. To find a y-intercept, set x equal to 0. Okay, now, the following says, write an equation for a linear function whose graph has the given characteristics. It has a slope of 5 and a y-intercept of 0, -3. Now, note again the y-intercept, that ordered pair, x is 0. So we know it's a y-intercept even if they hadn't told us that. Also recall that the letter M stands for slope, and the letter B stands for the y value of the y-intercept, going back to the y equals mx plus b that we used a minute ago. So this would become y equals 5x minus 3, but using function notation, f of x equals 5x minus 3. So there's a function with a slope of 5 and a y-intercept of -3. Let's take a look at another example. Here it says that the slope is 1/5, and the graph passes through the point 10, 1. All right, so we know that the slope is 1/5. However, the point they give us, 10, 1, is not the y-intercept since x is not 0. Okay? But here's what I can do. Using slope-intercept form, y equals mx plus b, I can take the slope and put it in the place of m. So we get y equals 1/5 x plus b. Okay. Then I can take the ordered pair that I'm given, and the x value is 10, and the y value is 1. I can put that in for x and y, and I get 1 equals 1/5 times 10 plus b. Now, all that is left in terms of a variable is b. So I can solve this equation for b. 1 equals 1/5 times 10 reduces down to 2. So 1 equals 2 plus b. Subtracting 2 from both sides, -1 equals b. Well, the slope is 1/5. The y-intercept is -1. So y equals 1/5 x minus 1. Writing it as a function, f of x equals 1/5 x minus 1. And there's our final answer. It has a slope of 1/5, and it passes through the point 10, 1. Okay, now, next we have a situation where it gives us 2 points. So again, write an equation for a linear function whose graph has the given characteristics. It passes through, let's see, 1, 7 and -2, 1. Well, again, if we could come up with the slope and the y-intercept, we could plug them into slope-intercept form. I don't have the slope, but if I use the slope formula, so we're going to review that, the slope formula looks like this. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. By the way, all of this is in chapter 3 of the textbook that you have. Okay, so if you need more review and you want to do it on your own, you could look that up in chapter 3. But anyway, continuing on, this is going to be point 1 and this is going to be point 2. Point 1 consists of x sub 1, y sub 1. Point 2 is x sub 2, y sub 2. The subs meaning subscripts referring to the points. Okay, so the slope is going to be y sub 2, which would be 1, minus y sub 1, which is 7, divided by x sub 2, which is -2, minus x sub 1, which is 1. 1 minus 7 is -6. -2 minus 1 is -3. And -6 divided by -3 is 2. So the slope is 2. Okay, so now we have the slope. So using y equals mx plus b, the 2 is going to go right there. So now we've got y equals 2x plus b. Recall in a previous example, once we had the slope, We took an ordered pair and plugged it in for x and y. I can use either ordered pair, 0.1 or 0.2. What I don't want to do is pick an x value from one of the points and a y value from the other point. I've got to stick with the same point. Let's go ahead and use 0.1. So 1 is going to go in the place of x, and 7 is going to go in the place of y. So 7 equals 2 times 1 plus b. 7 equals 2 plus b. Subtract 2 from both sides. B equals 5. So the slope is 2, the y-intercept is 5. Y equals 2x plus 5 as a function. F of x equals 2x plus 5. Let's check our work. Let's take the ordered pair 1, 7. F of 1 is 2 times 1 plus 5, which is 7. So that checks. Let's take the second one. F of negative 2 is 2 times negative 2 plus 5, which is 1. And that checks. So both our ordered pairs check. So final answer, f of x equals 2x plus 5. Okay, now this next one says, again, we're to write an equation for a linear function whose graph has the given characteristics. It passes through 3, 0, and it's parallel to the graph of g of x equals negative 2/3 x minus 4. Now, first of all, our ordered pair, 3, 0, that is an intercept, but it's not the y-intercept. It's the x-intercept, which is nice, but using slope-intercept form, we have to have the y-intercept. So this point isn't really anything more special than any other point in terms of this problem. But what about the fact that it's parallel to the graph of g of x equals negative 2/3 x minus 4? Parallel lines have the same slope. And if two lines have the same slope, then they are parallel. So that means, well, the slope of this first line right here is negative 2/3. Well, the slope of the line that's parallel to it is also going to be negative 2/3. Parallel lines have the same slope. So now I've got a slope and a point. Okay, so y equals mx plus b. I can put the slope in there. Y equals negative 2/3 x plus b. I can take 3 and put it in for x and 0 and put it in for y, doing pretty much what I did in a previous problem. 3 is reduced down, and I get 0 equals negative 2 plus b. Add 2 to both sides, and b equals 2. Okay, so I've got the slope and the y-intercept. Y equals negative 2/3 x plus 2 as a function. F of x equals negative 2/3 x plus 2. Let's check our work. Well, if the lines are parallel, they should have the same slope. 2/3, or excuse me, negative 2/3, negative 2/3. Let's see if the point 3, 0 is a solution to f of x. F of 3 equals negative 2/3 times 3 plus 2, which is negative 2 plus 2, which is 0. So it checks. Again, parallel lines have the same slope. And let's see, here's another example. This one, it says it passes through the point 1, 2, and it's perpendicular to the graph of g of x equals negative x over 6 plus 1. Whereas parallel lines have the same slope, with perpendicular lines, that is, lines that meet at a right angle or a 90-degree angle, the slopes of perpendicular lines are negative reciprocals or opposite reciprocals. So in this case, the slope of this first one is negative 1/6. Recall there's an implied 1 in the numerator, so it's negative 1x over 6. The slope is negative 1/6. Okay, the slope of the line that's perpendicular would be negative, the negative reciprocal. So it would be positive 6 over 1, or just 6. So you're going to change the sign and flip it over. Okay, so now we're going to use that slope and that point. Y equals mx plus b. M is 6. Y equals 6x plus b. Using the point, 1 goes in for x, 2 goes in for y. 2 equals 6 plus b, subtract 6. Negative 4 equals b. So don't forget to use the negative reciprocal slope, this one. So y equals 6x minus 4, or f of x equals 6x minus 4. Again, the slopes should be negative reciprocals, and f of 1 should equal 2, and it does. So our equation is correct. All right. Now, earlier I talked about, let's see, where was it here when I graphed this, that a function in the form f of x or g of x or whatever equals a constant is going to be a horizontal line, okay? Which means the equation or a function that describes a horizontal line would be in the form f of x or y equals whatever number that is. So what we've got now, it says, again, write an equation for a linear function whose graph has the given characteristics. It says it's horizontal and passes through negative 8, 12. Okay? Yeah. Negative 8, 12. Well, if it's a horizontal line, it's going to be in the form y equals a number or a constant. Well, the y value is 12. And then using function notation, f of x equals 12. So a horizontal line, y equals whatever the y value is, and then a function f of x equals that. Okay, now, earlier here we had an example where, let's see if I can find it, we were given 2 ordered pairs. And let's see here. Oh, it was later than that. Here. Aha, here we go. We were given 2 ordered pairs and we came up with a function. We're going to read an application problem. We're going to extract 2 ordered pairs and use that to create a function and then answer a follow-up question. So we're going to use an example that we did earlier here. So now, here's what the scenario says. It says, nurses. The demand for full-time registered nurses in the United States can be modeled by a linear function. In 2005, approximately 2,175,500 nurses were needed. By the year 2015, that number is expected to increase to about 2,586,500. Now, this problem obviously is 6 years old because it's referring to 2015. I suppose we could check and see if that really happened, but let's not worry about that right now. It goes on to say, let T be the number of years, so think of T as time, the number of years after 2000, and N be the number of full-time registered nurses needed in the US. Write a linear function N of T that to model the demand for nurses. Okay, so T equals number of years after 2000, and N equals number of registered nurses needed. Okay. All right. Now, and our function is to be written in the form N of T. So that means T is the input and N is the output. So ordered pairs are going to be in the form Tn. Okay. Now, recall, or let's look at it. T is the number of years after the year 2000. So for instance, when it says in 2005, T would just be 5. All right. It says in 2005, so that's 5 for time. The number of nurses is approximately 2,175,500. So T is 5, N is 2,175,500. Okay. Second ordered pair, it says in the year 2015, so there T would be 15, expected to be 2,586,500. So there's our two ordered pairs. We'll call that point 1 and point 2. But again, notice the T values are the number of years after the year 2000. Okay. So first of all, let's find the slope. Now, technically, we're not using y2 and y1. It would be n sub 2 minus n sub 1 over t sub 2 minus t sub 1. But I'm going to just use the formula in terms of x and y. When we get all done, we'll put in the right variables. Okay. So we're going to have that minus that over that minus that. Y sub 2 is 2,586,500. Y sub 1 is 2,175,500. X sub 2 is 15, X sub 1 is 5. All right, so in the numerator, 2,586,500 minus 2,175,500, and I get 411,000. 15 minus 5 is 10. Taking the numerator and dividing by the denominator, you get rid of a 0, you get 41,100. So there's your slope, okay? So using y equals mx plus b, that would go in the place of m. So y equals 41,100 x plus b. I've got two ordered pairs. I can use either one. I'll use this second one here. So that's going to go in the place of x, and that's going to go in the place of y. So I've got 2,586,500 equals 41,100 times 15 plus b. 2,586,500 equals, let's see here, if I take 41,100 times 15, I get 616,500 plus b. Subtract 616,500 from both sides, and we get, let's see, 2,586,500 minus 616,500. I get 1,970,000 equals b. So y equals 41,100x plus 1,970,000. But using the correct notation, it would become n of t equals 41,100t plus 1,970,000. So there's our answer to that question. Write a linear function n of t given those conditions. All right. Now, there's a follow-up question that says, use your answer in part A to predict the number of full-time registered nurses that will be needed in 2025 if the trend continues. So 2025, T would just equal 25. So I want to find N of 25. So N of 25 is going to be 41,100 times 25 plus 1,970,000. So I take 41,100 times 25 plus 1,970,000. Let's see here. And I get 2,997,500 registered nurses. And there you have it. So you're going to want to review things like intercepts, slope intercept form, the slope formula. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals. An equation in the form y equals a constant is a horizontal line. The slope of a horizontal line is 0. I didn't use these, but two other things. An equation in the form x equals a constant is a vertical line, so it wouldn't be a function. And the slope of a vertical line is undefined. Okay. Anyway, lots of information there. So tonight, finish up section 8.2. I'm going to stop the recording